Hello. Today we're going to take note 6 on factoring. What we've been doing for the last couple days is we've been factoring the greatest common factor. But today we're going to start working on factoring something if there is not a greatest common factor. So if we have a problem like this, x squared plus 6x plus 7, if I look at each of these terms, there is no GCF. There's nothing I can take out of all three of those terms. And so when that happens, we have to factor a different way. And so we're still always going to try to factor on a greatest common factor, but if we can't, then we have to have another strategy. And so that's what I get to show you today. And so these are, like I was saying, notes 6, and we're going to factor when they're in this form, x squared plus bx plus c. So we're going to start with a little bit of background information. When I talk about these, I'm going to talk about quadratic equations or quadratic functions. These are quadratic. Quadratic functions typically have 3 terms, and the degree is normally 2. That means my exponent is normally 2, just like this equation. If you look, the biggest exponent is 2, and it has 3 terms. So this is a quadratic. Okay. And quadratics, just like everything else, I mean, it's just a type of polynomial. It's just a special kind of polynomial that only has 3 terms normally, and it definitely always has an exponent of only 2 as the degree. And so this is standard form. You're going to hear me talking about this a lot. X squared plus bx plus c. And we have to be used to the fact that b and c are just numbers. They're numbers in this equation. The x's are going to be my variables, and b and c are the numbers. And so in this example, x squared plus 11x plus 18, my b term is 11 and my c term is 18. And it is critically important that we're able to identify what b and c are, so let's practice that. Here are 2 examples, and I would like you to try to tell me what the b and the c term are for each of these 2 problems. So can you copy them down and press pause and try to think about it on your own? So when we're looking at this, you can press play. Hopefully you pause and actually thought about this answer. But for this, the b term is 8. The b is the coefficient on just the x. And then c is the constant. I think that's why they picked letter c, because it's the constant. So c is the number alone. So in this case, the c is 7. And then for this next one, my b term, we have to be careful. You see how it has that negative there? My b is negative 11. You have to include the minus sign. You have to like add the opposite, and you have to see that as a negative. And then the constant again is the 10. That's the c term. Okay, hopefully with that background information, that will help you get ready. Last night or yesterday, you were supposed to work on a worksheet that looked like this. It said factoring quadratics at the top. And I asked to see if you could find any similarities. So these are my answers. You can go ahead and check your work, press pause and go and find it, and actually make sure you did it correctly. But there are some pretty cool similarities when you look at these. When you look at this work, my numbers here are 9 and 2, right? 9 and 2. And the cool thing is, watch, if I add 9 and 2, I get 11. That's my b term. And if I multiply 9 and 2, I get 18. That's my c term. My b term and my c term. So when I add 9 and 2, those are the numbers in this problem. When I add 9 and 2, I get the b term. When I multiply them, I get the c term. And that amazing pattern is true for every problem. When I add 3 and 4, I get 7. That's the same as b. When I multiply 3 and 4, I get 12. That's the same as c. 7 is found when I add, and